Hello. On this stream, I went over a B tree that I implemented off stream. I did it like yesterday, and yesterday's yesterday. uh, so I did it off stream and I went over it. This is the first 36.5 minutes of the stream, and then I went over to trying saving on disk, like saving the. I mean, I wanted to save the table on disk, try and do this, but I was able only to, in 3 hours, I was able to just like save it, do it with the column. If you're the column struct, if you remember, this is the column struct is have a name and the uh, stood variant of vectors. So yeah, so I did. So I was able to serialize it and deserialize it. It was, I mean, it was kind of long and I didn't really understand what to do at the beginning, but I think I understood it. I hope um, the next part where I have to serialize for the table and the B tree, it will be easier, I hope. And I mean, not easier, but like I hope I know that I now understand it more. It will have like will be more, will go smoother. So yeah, and don't forget to subscribe and hit that like button if you like what you see, like what you saw, liked what you saw, and enjoy. Hello, hello. This is building my own DBMS. I am Ellie, and yeah, sorry for not streaming the previous week. I couldn't. I had some school projects I had to work on in C. Sadly, I hate C, but well, you gotta what you gotta do. Because as you can see here, this is not the DBMS project. That is correct. I'll go over to the DBMS project soon. This is I built previous stream. I was trying to build a B tree. It didn't go well. So yeah, I finished it here, like off stream, off camera. So this is the B tree structure that I'll be storing, using to store keys, IDs of tables. So for fast lookup, and because it's stored on the disk and it's not on the RAM and it's slow and stuff. And today I think I'll mainly focus on serialization. Sorry, I'm gonna mute my phone. I'm gonna focus on serialization of the tables and storing them on disk, file disk. Yep. We'll see how it goes. I never used serialization before, so it'll be fun. But I don't think it's that hard to use serialization. Also, in this B tree, I didn't implement deletion yet. I will implement it later, but not this stream probably. It's kind of confusing and I don't like it. Anyway, but I'll implement delete later. For now, we have insert. Okay, so I'm gonna go over this B tree and then I'll be back for I'll go back to the actual DBMS project. So okay, I think I'll try to explain what a B tree is, because yeah, but I'm not the best. I don't have the best understanding of it. Well, I'll try. Well, first of all, a B tree is like a binary tree, but it has more then it can have more than one child. So it stores, it has an array of children and an array of data, which is keys, usually mostly integer. Like I used integers, I think, like yeah, because you have to compare like a binary tree, right? So we have max keys. Minimum keys is not like minimum keys. We need to know when deleting. So when we reach max keys, then we have to do something called split children. And yeah, so the root is the only one that is allowed to have one key in it. The other is like everything that it isn't. That's not a root. Don't have that luxury. So let me show you. I don't know. But I'm gonna delete it anyway. So let's say we need to insert into this B tree like 1, 2, 50, 30, 31, and no 7, 1000. Okay. So the root will have like the median. Let's have yeah, okay. So median value here is 30, right? No, it's 50. The median value here is 50. So it will be 50 in the root, and whatever to the left of it will be smaller than it, and whatever to the right of it will be greater than it. But we can have multiple keys on the same, node, right? And we have multiple children also. So let's say we want to insert, first of all, let's say 50 as our root. So this is what we want to insert, right? So I want to insert 1. What do? We go to the leaf, to the appropriate leaf. At this point we have only the root, so the root is our leaf, and we insert it in a sorted fashion. Like in my case, I did it ascending order. So we insert 1 into the root, like that. Okay, insert 1 to the root. Okay. We actually don't have enough keys, I think. Whatever. Now we want to insert 2. Also insert until we reach the maximum keys, which I set to be 4, right? So insert 2. Now insert 30. It will be here. Okay, we reach the maximum, but we can have max up to 4 keys. So 30, and now when we want to add 31, we have overflowed. So what do? We take the median value after insertion, right? So after the insertion of that overflow, so we take median value. In our case it's a root, so we put it above it, and we split the children. So now its left child have 1, 2, and this one has 31, 50. Now it's 67 and 1000, so it goes here, both of them, right? We search for the appropriate leaf. Let's just copy paste it. Okay, let's actually add these to differentiate between nodes. Now what will happen if we want to add to this node another key, let's say 32, right? Want to add 32, so we add 32 and now it's overflowing again. What do? We take this, the median key, split it, so now this will be the right child of this and this is the left child of this. So 50 here, and this is actually will look like this. So as you can see, let's actually also delete spaces for clarity. So now the root has 2 keys and it has 3 children. So the leftmost is less than 30. The middle child has values between 30 and 50, and the right child has values above 50. And it will go on at insertion. This is good, I learned, for storing files because it won't go deep, like the levels, it won't add too many levels at each, how do you say it? Like it won't be too tall compared to, say, binary tree, right? And it is good with disk storage because data retrieval is pretty data retrieval, right? Yeah, data retrieval is pretty slow, so we'll need it. So we'll have to, but here we only have 2 levels, so we search, like we want to search for 32, we go like, okay, 32 is between those, then it's the middle child, and we search here. It may be slower than a binary tree. I don't know if it's like if it's on a RAM or something, it may be slower, if I understood it correctly from what I read on Bitrees. But yeah, this is the shortcut works like that, and it only gets deeper when you split the root. So it takes a lot of value, so you have to you have to add more and more values to split the root, and then you only then can add another level. Also, property of B-tree is all the leaves are on the same level, like it's the same depth always. If it's not, it's not a valid B-tree. Now, I didn't test my B-tree that much. I hope it works good. I had some issues printing it in a nice fashion. I did implement a print, but it's not the best. I'll show you what it basically does. And this is a lot of values, but I don't think it creates like 3 levels, I think. So I don't have a lot of test cases. I hope it works. If it won't work, I'll try to fix it later if I see something that doesn't work, stuff like that. So let me first run this. Let me run this and show you the output. Let me took it this time. Okay, so this shows the level, like each level it doesn't show the nodes, so that's 3 levels. So first level is the root, we only have 1 value here. Then we have I think that's, so 14 is less than this. Yeah, the root has 2 nodes, so this is great. This 4, 6 is less than 8, then it's here. 9, 10, 12 is between them. 15, 16, 18 can be either to the left, to the right of this, or to the left of this. Then check 21, also 21 and 22 can be some of them here and some of them here. Then 25, 26 is in the middle here. 28, 30 is here, and the rest are to the right of this. Yeah, that's 4. So we have. I don't. I think it's about search. I checked that there are no overflows. I tried to check there are no overflows, but yeah, I did it yesterday. It took me quite some time, and I wasn't able to check a lot of it. And I want to do actually interesting stuff for this stream. So I'll try to go really fast, like maybe 10 minutes on what I did here. I want to go too in depth. If you are interested for me to go in depth, I can. Like, I don't know, ask in the comments or something. I will try to explain exactly what I did and why I did. But yeah, so we have first we have the B tree, which will have the which will store the root node, and we have the node. So I'll start with the node with individual nodes. So we have max keys for the maximum keys, and minimum keys doesn't matter right now within that deletion. And max children is 5. It's supposed to be 1 greater than the max keys. Now, the array of keys, I have max keys plus 1 here because I first of all add a key, then I check for overflow, so I can take the median with respect to the added key, and not take the median before I add a key. Same with children. Okay, so insert key non-full is inserting key assuming it is the keys are not full. So I call it only when I know it's not full. Split children is the main brain, let's say, behind the inserting of keys. I'll go over it really fast. So we have less than key, more than key, right? It's like left and right in a binary tree, but a bit more complex, I'd say. So we take the median keys. Now this function assumes that it is already overflown. So our keys have five keys in them. So it's overflown, and we create like it's supposed to be the maximum here can be 3, but because we're splitting, so it won't have all the values, right? So we take the median key, which is at the middle. When we divide, like we have when it's overflown, we have an even amount of keys here. So when we divide, it will take, say, 5 divided by 2 is 2. It floors it, right? Unless we take negative numbers, it floors it towards 0. So if it's negative numbers, it goes up, I think. So at index 2, and it will be in like 0, 1, 2. That's the median key because we have 3, 4, right? Partition copy. This, if you don't know what this does, it's an algorithm from the STL. What it does, it takes a range. In my case, it's an array, right? So from begin to current size, it should go to the end. Like it doesn't matter. Current key size is supposed to be 5, right? Because again, we overflowed, and it takes the first begin, like the first range. It takes where to insert when this functor or lambda or whatever, right? When this returns true, it will store the value here, and when this return false, it would store the value to this range. So if it's less equal, and yeah, it would store the median key, but it is fine. I accounted for that. I hope you don't hear that outside. Hope my mic don't catch it. Those voices outside, it's kind of annoying, but yeah, tell me if it need to be fixed or something. So yeah, so what this does is basically here stores every key that is less than median key, and here what is greater than median key. So now keys, like the current node, right, will be the less than, so the left part of this. Let me just a second. I'm gonna close my what's it called close my window. I don't know if you can hear that, but it's kind of annoying. Just a second. Thank you, thank you. I'm so sorry. Uh, I muted my mic through here and I didn't see it. Thank you. Hope that wasn't too long. Anyway, thank you. Okay, so again, we have two keys to the left now and two keys to the right, and the current children size also is divided. But now, the children are not even. Like we have 5 maximum children, so I did it so the children to the left will have 2 children, and the right will have 3 children. It doesn't matter, I think. Like you can, as long as as long as both of them have combined 5 children, right? So in this case, it rounds down to 2 children. If max 5, like depends on what you set. And the more node is the same. Oh, the less key will have the median key, which is supposed to go to the parent, right? But because the current key size will be 2, it will take only the first 2 values. And the median key will be it will be inside the array, but it won't be active. Like you can't search it up unless you don't use current key size and you go through the whole array, even through the values that are not supposed to be accessible. Like you can still access them, but as long as you go through the current key size, you can't go, like you still have only the 2 values and not the median key that is also added here. So yes, so this won't actually include the median key because it is always will be to the right of the, it will be on index 2, and because the key size is 2, it will only contain indexes 0 and 1. And same with this. Again, this will be 2, this will be a current children size, So this I already divided this current children size by 2, so I'm just I'm not I'm forgetting words sometimes. I'm just saying equal. Okay, I'll say equal. So this will be equal, current children size of more node will be equal to current children size. And then more node from 0 to his current children size. I'm copying from children, like from this children, right? And offsetting it by the same amount, because now we have left children and right children, so this will contain from, sorry, where is it? This, right, this node will contain children from 0 to current children size, -1, we say indices, sorry, and this will contain those after. I hope I don't have here error, like error of by 1, because I think one's supposed to have 2 children, the other is supposed to have I don't remember. I from what I tested, it's fine. And I'm returning the more node. So here, what I'm doing, instead of creating like 2 new nodes left and right, and then I don't know, forgetting all this, it becomes the less node, and I'm returning the new more node that I created from this, from copying this, like splitting this, sorry. Okay, now try to finish it faster to go to the actual fun part of storing on disk. So insert child is just inserting child in the current place. So the children that have keys should be like, because we have a bunch of children, so children have keys from 1 to 10 should be in between children, so say that have between 1 8 and 1 to 10. Let's take 5 6 should be between 3 4 and 7 8. Okay, so I'm just comparing and offsetting, like moving the children, and here and I'm saying now children at I, where I got here, right? I stopped here, so I is now either 0 if all the children are keys are like bigger than it, and I'm just saying children at I equals to the child that I want to insert, and importantly increasing the current children size because I now inserted a new child, so this is also important to add because then it won't work. Split root I added because it's like it's same as split children. It actually uses split children here, I think. Yeah, but it has the special case that it doesn't have a parent. So I create a new root. I insert this root split children, so it will have the right part of the current root. Keys at 0 equals to these keys, this, I forgot what I did here. These keys, this current key size, well, I don't know if I even need that. I forgot what I did here, because oh, right, I'm supposed to insert the median key here, so split children and the median key. So the only key, when I split the root, it will have only one key, right? So the key is the median key, right? I remembered. And after the split child, the median key will be at an inaccessible for this for the splitting already, right? Because current key size is the size. So if we have size 2, it will have only indices 0, 1, and at index 2 is outside of its current range, but we know that it is the median key when we did split children. And then I insert this also, like insert the root. New current key size is always will be 1 here after root split. Now I set is root to true, and this, which was the root before, is false. So now let's switch the root. Who's the root, right? And the current children size is 2 again. The amount of children is either 0 when it's a leaf, or current amount of keys plus 1. And we return the new root because we need to set it in the B tree here, like after we change. Okay, it took me quite some time, so I try to be even faster. So insert and split is a recursive function. Again, so it's inserting and splitting if needed. So first of all, I insert key non-full. Now I don't check if it is more than max keys because I check. I always have plus 1 here, right? So I can insert 1 over the limit because I want to find the median key. Sorry, I want to find the median key after insertion. It's more probably better ways of doing it in case to assure there's no overflow. But this was the easiest way I thought about it. So after insertion, if it is greater, so if I'm overflowing here, right? I'm checking if it is a root. If it is a root, I'm doing split root and return. So just splitting a root and ending this function, don't need recursive or anything. Now, path stack. This is again the way of inserting is searching for leaf where I could insert. So I go down the tree, search for a leaf that I can insert in. Now, in this function, I actually want to go the logic of it. It's not that complicated, and I'm taking too much time explaining this. So basically, I just find a leaf, and to the way to the leaf, I add it to. I push to the node stack, the path, because I need to know what the current parent is. So after popping, because at the top of the stack now is the current node, supposed to be the current node. So I'm popping, and the top is now my parent, and I'm inserting child, current node split children. So I'm doing split on the current node and inserting child here. Again, so it will have 1 new child and 1 new key. And I'm doing insert and split on current node keys. So this is the median key, right? This is again, it is out of range because we work with indices. Again, it's if we're size 2, then only index 0, 1 available, but I'm taking index 2, and this will be the median key to pass to the parent, to add to the parent. And I'm passing the path stack top, so the parent of the current node. And again, I'm inserting the median key that was passed here and checking it again and doing it recursively until, I don't need, until this condition is not met. Then I know that inserting key didn't overflow it. So again, this I won't go over it really. It just pushes nodes. If it is a leaf, then I have to stop because I found my range, right? And here just searching if it is in the range, searching what path should I take, like left, right, middle, and so on. Insert key is just checking if root is null. So if root, like if no values were inserted yet, I'm just creating the root then. Then find key range leaf and inserting. This fills up the stack, inserting the top and the key. And after the insert, I am just emptying the stack. Yeah, printer, I want to go over it. It's not really that good. It's just like it just prints by level, like it goes level by level. It was kind of annoying. So yeah, here it just inserts and it apparently works. It didn't cause a segmentation fault after a lot of time, and as you can see here, it did work. I also went into debug mode and saw that the keys are in current places. In right place. So after half an hour explaining this, we can now get to more interesting things about the DBMS. And I will switch to that. I will copy the code from here. Well, let's first switch that. Yep. Let me go here. Oh, you don't. Why is that? Why is it black? It's B3. Does it not recognize it? Oh, yeah, I have. Okay, it is. I have the previous B3 iteration that didn't work. Yeah. So let's just delete this, everything. Fuck it. And in not problem ones. No, I will keep it. And B3 CPP also. Yeah, as you can see, it was kind of messy. I actually died stream. I'm gonna copy the print tree also here. And I'm just copy this into not the correct one. And this is HTTP. I think I have to pragma ones. I do. And in here, CPP. Copy this. Oh, and I have probably to. Oh no, I have streaming there. Okay. Yep. Now I can close which one of those? This. Also, this is probably small. I'm gonna, yeah, increase the size. Okay. Yep. Oh, and just, you know what? I'm gonna add it to Git. So add this, Git, commit, minus commit, minus add B3 implementation. Right, and git push origin. I hope it actually works and I didn't just push something that doesn't work. Yeah, that's fine. I think chat is not displaying here, but I don't know what to do about it. Okay, where was I? So let's go and see here. I'm gonna just serialize, like add all the serializations here one by one, like when I need something new, I just add it here, I guess. For now, I want to get my feet in the water. Feet in the water. Yes, let's just try something. So this is. So I need an off stream out and just guessing all. Yep, and just everything it contains. Okay, so let's open table HPP and have. Okay, so we have a vector of content. So vector of columns. So wait. That means I have to serialize until. So I have to serialize have a serializer for column. Then for the rest of the table, all right. Well, let's start with it. I guess let's start with serialized column. Let's have let's avoid serialize column. Okay. Column. Okay, and let's start with it. I think it will be the easiest from all the thing I need to serialize. Well, let's actually start with this, right? So serializer. Okay, now let's open. Oops, not this. I just need. Where did my table HTTP go? Here it is. Okay, so column, column, column. We have name and we have a vector entries, like variants of vectors, which is fine. Where did I define it? I think it in the common HTTP thing. Yeah, varvec. So that's a variant of vector int, double, char, and string. So let's see. Well, the easiest one, it's name, right? I think it's name. Yep. So that's the easiest. So let's have. Oh, wait, where was it? The code. So. Oh, and I need, I guess, to the upstream. Yeah. Okay, I'm definitely gonna change it, but I want to serialize something, so I start with that. So let's have. Let's just copy this out. Okay. And here. Okay, so yeah, okay, so we need to provide right. Also, I'm gonna, because why not? I'm gonna open OS cp fstream right offstream right. Let's check. So what write does, the function simply copies a block of data without checking its contents. The array may contain null character, which are also copied without stopping the copying process. So, yep, and reinterpreter, because that's the most important. I think that's just casts into binary, I think, right? So let me that's in C++. That's geeks for geeks, but I think it'll be fine. No, you know what? No, we have a CPP reference here. The reinterprecast expression does not compile to any CPU instruction except when converting between integers and pointers or between pointers and obscure architecture. Blah, blah. Converts between types for reinterpreting an underlying bit pattern. Why into const char? This is what we write, so I guess it takes only const char to write. Doesn't take strings. Well, let's see. Let's see. So I need size t size of name equals all dot name dot size. Right. It's actually the same as here, I'm guessing. So outright, I can actually just copy it. I don't just this. Okay, so what do we have here? So we have here the same same thing. So reinterpret cast into const char the name length and size of name length and out.write name.c string name length. Oh, nice. It have here. So variable string insertion returns this character are copied from S and inserted into the stream until one of the following happens. And characters are inserting into the out sequence fail. This can so yeah, we need to provide the length. Okay. Now I need to serialize the where is it? I'm going to serialize the entries. Okay. So this to happen, we need to know what kind of entries are there. Stud visit again, I guess. Would even have help. Let's see, size the size of entries. Start with 0. Now yeah. How can I get the size of this? Like, well, let me think. Let me think. Okay, so the problem only if there are strings, otherwise we can just use the size of right. So if stud is no, where is it? I used it somewhere in table CPP. Holds alternative, right? So if it stud holds alternative, and how was it again? Here. Let's put it here and this put here, and we don't common HTTP. Okay, so holds alternative, and we just plus and what it holds. So alternative stud vector string um dot entries. Okay, so for string colon entries, then I need to calculate the length for it. God. I just serialize it one by one. Okay, so because I don't know what's the name, like how big are the strings there, so tune vectors to this string str entries, right, of equals call dot entries stud get, so just stud get stud vector call dot entries, right, and for auto entry in your entries, oops, stud vector stud string here, stud vector stud string, okay, for auto entry in entries, then we just do the same, size entries plus, no wait, I need to, yeah, oh, yeah, I don't need if. Aha. To visit, yeah, I'll use it. I don't think string will be any different, so stud visit. First of all, dot entries, right? All dot entries, and for core okay, so it's stud visit. We have this and the template and the vector. So, and like the lambda, yes, the lambda. So we have the capture list, which is size of entries. No, I don't need size of entries. Capture list. What do I capture here? Do I need to capture here? Out. I need to capture out. Out. Because I need to outride and actually that's it, I think. So class T and let me check it again. I didn't use stud visit in the I mean, stud vector of stud vector T. How did I call it? I'm not good with it. Current call entries, that's a bad name. I'm gonna use different thing. So back type. Right. That's definitely a good name. Also, I want to check why the chat isn't showing. Like, or am I just blind on test? What the fuck? Oh, I see. I have to log in every time in my Streamlabs. Okay, so today the chat won't be showing. I'm sorry. I'll do it later. Navigator. Okay. Now, 4 T entry. That's actually entry is a type definition, not type is I'm using the keyword entry. So T, let's just go with current entry in check type. Okay, so what do we need? We need size D, size of entry. Let's start with 0 and think about how to catch the size. So can't just go with current entry dot size. Let's see what tricks I used here with this. So actually with this, it's and here, I didn't use size here. How do I get the size? If it is a string, I need to do something about it because I need to know the size of the string. It is, well, it is basically a pointer, so yeah. So if, okay, let's go there. If stud is same t stud string current entry, then I'm gonna I can't just use get stud string to serialize equals stud get that won't work, right? So stud get stud string. Yeah, I can't get on a current entry. I can only get. Maybe I do need different thing for string because I need to convert it into string. I can't. Oh wait, I can't do it. I can just do this, right? So let's build the thing and check if. Okay, it doesn't cry or anything. Okay, I can do that. Right, I forgot. Wait, then. Yeah, just okay. So out. I can just do that. Out. No, if it in the same size of, then your size in length. Size of entry. Wait. Oh, I have here. I have an example. If it is an int, the name C string name length. Oh. No, wait. Sorry. So size of, just size of. Right. So this in the case of a string and this in case of anything else. So in here it should be equals to, again, where is it? Fuck. Where was it? On temp, I think. Right, so interpreter cast, I'm casting this and giving the size of this. And yeah, okay, I get it. So I'm gonna do that. And this is not yet, size of entry is 1. If it is string, then size of entry times, or just equals 2 yeah, would string str entry equals current entry equals str entry dot size. Okay, if it is like that, it's done. And out dot write, where was it? Out dot write interpreter cast to const char. Do I need a header for interpreter cast? I forgot. I don't think I need a header. Yeah, okay. So write just a cast and the size of, okay. So wait. Oh, we need to, okay, we need to cast here. We need to cast the length. We want to save the length and then write it into this. So it will be a bit different for, okay, let's just go with both cases. So this size t r length, okay, and now do out dot write std interpreter cast. Is it just, it's not std, right? Interpreter cast const char of string length was like that, I think, right? And size of string length, or just size of size t? It doesn't matter. I don't think it matters because it will be the same size of string name length and if so size of and we just, oh, we need, and we need to cast a C string. Okay, so size of str length and out dot write str entry dot c string, and we need to give the length, right? Yeah, length. And then str length. Okay, this is in case of string, and in case of anything else, it is just gonna be out dot write interpreter cast const char where is it? Current entry size of current entry. Okay, this should do. I hope. Really, really hope. Is it everything? I think so. So, right. Mm-hmm. Right. Boom, boom, boom. Supposed to be. Let's try and build it. Okay. Doesn't complain. But let me just check if it will complain, because this is not complaining for some reason. Now let's build. Now I don't like it. Oh, it doesn't have. Okay. Think I know. I think I know. So let's include serialists. What the fuck? Hmm? Serializer dot HPP. Don't know what that thing was. Okay. Build. Okay, and if I do that, it should give me... What the fuck? Oh my god. Source files is serializer in source files. Is in source files and serializer.hp is in source file. Let's create. Fuck it. Let's serializer stir. Okay. Build. Huh? Let me restart this. I know it's not picking on stuff. Also, let me here. This is all the tests. I don't care for that. Maybe maybe I need head to. Yeah, finally. Yeah, that's not good, but at least okay. Namebank was not declared in the scope. What do you mean? Oh, I forgot. Oh, I forgot to get it back. Of course. What? No. Okay. Sorry about that. So, it does seem to work. Build. Okay, what's that? Name string names. Yeah, of course. Let's call it name. Name. Oops. Build. Okay, what's up with that? Would not convert current entry from int to into blah blah blah. What? What do you mean? What did I wait? Where is it? I guess I needed to update the called gimmick list. Anyway, it did work here. I think has it good. Oh, const expert. Right. Const expert. That should be fine. Good. No, that's fucking weird. Oh, that's double dotted. That's not okay. Build. Now what? There is not a number of. It's const expr. Should be fine. Value. Wait. T value. What's value? Stud is same T int. What the fuck is value? Oh. Why I don't need to pass fucking Jesus. Now that's fine. Okay. I don't need to pass and to check if the T and stud string is the same. I don't care for that. The value is part of the. I mean, I know I understand C++ syntax, but sometimes I just forget about, like, just don't think about it. I think value is part of stud is same, and it gets like, yeah. Anyway, sorry. Yeah. So I built it fine for now. Okay, so this seems fine. This is definitely fine, and let's deserialize it also. Let's serialize column and with deserialize column. Should now is that? Yeah, that's an if stream and in. And we need to read it and just give it size of memory size. Yes, okay. So where was it? Stud if stream in. Right. Do I need to pass anything else? Oh yeah, the column serialized. Also here I can do that. And here it's const build. What the fuck? Is it like I don't see even the squiggly line. Where's the error? What line? Stud visit. Oh. Stud visit const. Right, const. That. That's just, that doesn't work like that. Can I stud visit a const? Visit const. Oh wait. Const. Here, right. Stupid me. Nice. Yeah, so sometimes I just don't think. Okay, and this, let's just okay. So now we need to read it. Again, let's go reference our temp here. I am hungry. I have cookies here. I'm really hungry. Mm-hmm. Okay. Again, let's size t. Oh, again, like here. Where is it? And here I don't know if that's a string or not. Okay. So again, we can deserialize just anything, but um, but if that's a string, we need to pass an extra. Like we need to resize read in read. Is dot that? So resize name length, but I don't need to do a resize. I don't need to do a resize if yeah, if that's okay. Let's see. Name length. Again, that's a different story if that's a string or not string. Of course. Fucking strings. Okay, so I think there's std visit, I guess, right? Std visit. No. Wait. How do I know what type did I serialize? Hold on. I need to save the type that I serialized. You know? Because oh. Interpreter cast into age. Why is that? Wait. Don't we need to cast back? What's here? Let's serialize. Okay. In file. Okay, this serialize close. Okay, that's just that works. Let's try. Let's try. Let's see. I'm not sure. I'm sorry. I'm not sure how exactly that works, but maybe that works. So this I understand. Why is here a interpreter cast of age? Should read into a. Let's wait. Should there be like? Oh, I guess it doesn't want to side with me. So I'll type in. Okay. Okay. So let's first of all let's deserialize the column name. Right. So size t size of name 0. It's right 0 and deserialize it's in dot read. column dot name equal. No, wait, that's the second one. Sorry, that's here. That's a cast. In here, that's a cast. I'm pretty sure, right? So interpreter cast and then I'm resizing, and then okay. And resize if that's a stool string. I don't know, but let's see. So read the interpreter cast const char. Is even const char in here? No, that's not const char. Maybe that shouldn't be const char. Let's see. In here, char. Size of name. Size of name. And all dot name size, right? Name and in read interpreter. No, not interpreter. Sorry, that's call dot name at 0 and size of name. Okay, now the hard part. Yay. Again, I guess let's do the visit. And we need the in class T, and no, not a const. I don't, because I mean, still can, I guess, be const. I don't know. Entries. Vectype. That was vectype there. It will be now. Wait a fucking minute. No. Oh god, that's not how it works. What I'm gonna catch? Stood visit what? Column. Column is not constructed yet. Oh shit. No. I'll need to if I don't know, wait, if I don't know, size of, don't know the size of, I need to right. Okay, I need to save the vector size, I'm guessing, right? To read from it. I need to set the vector size. Know where to stop, so size T and entry size 0, and in here I guess the entry size. In here I am increasing entry size, and here I also write, so out dot write interpreter cast char, oops, char entry size and size of size of entry size. Okay, so now we have a size at the end. Wait, no, we need at the beginning. Fuck. Wait. That is hard. Okay. Holy shit. Uh-huh. Yeah, I need to enter serialize vector size. Nice. Should be the same, but I can't just do. Okay. Yeah. Okay. Just I don't know why I did that. Let's just do another student visit, I guess. Visit. Out and oh, I don't induction with this. Wait, what? Entry size. I'm not choosing entry size. This. Okay, so out plus p const stud vector 3 vectype type and yes. Yeah, that's fine. That's fine. So where is it? Out dot write interpreter cast r. Sorry, I am sorry. It's my time. It's my pill time. Interpreter cast. Cast vec type. Oops. Vec type dot size. Right. Okay. Yep, size and where is it? Size of type dot size build. I am. How much call visit serialization? Oh, I didn't provide. Sorry. All dot entries. What the fuck? L value requires a unary operation. Yeah. I need to pass a reference to it, right? I hope not. Okay, so now we have the size. We should have the size. Okay. And now we need to so size T, size entry size 0, and so in dot read interpreter cast char. Still not sure why I'm using an interpreter cast char here, but I don't know. I'll search it later, I guess. That should be size of no size of is like that because they're fancy. Size of entry size. Okay, so now we have for loop. Yeah, so stud visit all dot entries. Oh wait, why the fuck stud visit? No, for size ti equals 0, I is less than entry size. Right. Right, we're back to the problem. How do I decide which vector do I, like, just so here we have outright current entry and size of entry. So we need to decide. How do I decide again? How do I decide if I don't know? We can write the type somehow. I don't know. Can write type. I mean, serialize the type. I don't know. So yeah, can't really know what entries are stored there. No. How to serialize string variant? Holy shit, decay and decal type. What is that? I don't understand the code the ChatGPT generated. Variant index. No, we have variant index. Right, right. Let's see, wait. Index. Let me see. So since the zero-based value that is currently held by the variant. If the variant is valueless by exception, returns variant n plus p equals abc. It's 1 and then 0. So, alright. Okay. Doable. So, size t. Size t. Distinct. Int var index equals 0. Wait. Do I have get index? Variant. Let's see. Get if. No. Variant size. That's the size of the variant list. Alternatives at compile time. That's the type of the alternatives it's in the compile time. Variant size. Variant size provides access to the number of alternatives in possibly CVQ qualified variant as part-time constant expression. What? Int 1, int 2. Oh, the amount of. Okay, no, that's not interesting. Checks the variant is the valid state. Then zero-based index of the alternative held by the variant. So we gotta like hold alternative or something. It's to visit. Dot index. So yeah, okay. So we just where is it? So this column. This wait, no, let's yeah. So out right. Right. All right. Sorry, I was thinking. So out dot right cast char, that fingering again. Char column dot entries dot index. Wait, dot index. Yeah. Okay. Dot index. Dot index. I say. Jesus. Oh, that and size of size t, I guess. Right, because it's a index. So wait, I need to actually check it. Yeah, it returns size t. Okay. So size of size t. Okay, now we have index. So entry size. First of all, we have index. We have index before, right? Yeah. So entry size. Size. We have size t. Var index. Yeah, var index equals 0 in dot read cast char var index and the size of var index. Okay, now we have the index and yeah, just right. So size t var index equals 0 and then read da da da. Now we know what type of vector it is. Oh, do we need to create like different it's called sorry, do you have to create like different like all possible types like vector fins da, 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 or just pop, pop, pop. Okay, let's go with let's go with stud. Should I do stud variant here? So like stud variant and add all the possible let me think. So oh, I know, wait. Do I? Yeah, I know. Switch entry size. Right, so 0 is we need to go track entries, so common HTTP. So we have first of all it's int double and short and string, so that's int 0. what is it? So switch 0 all dot entries equal vector beat, right? Int case 1, that's a double, so call dot entries equals to the vector double break. Case 3 is all entries equals to the vector chop. That's the way. Wait, am I using it correctly? Wait. Yeah. And that's what I did there, and it worked apparently. And case 4. Oh, that's wait, break. Break. Case 4 call dot entries equals to the vector string. And default might just split out unknown entry index, entry type index, and entry size. Entry size? What? Not entry size, you var index. Unknown var index. And that's supposed to be var index. Okay. And now we can finally add entries to it. We can use studVisit. Let's actually not use studVisit every run before. Let's just studVisit. Call it entries here. And capture list. We need in, we need call, and we need we need entry size. Entry size. Don't need to change the actual. And here class T. So what I'm going to do is, because I created here, like initialize the vectors, the studVisit will work. Like it will know where to go, and I can deserialize the entries. Just I need to remember that. Where is it? To remember if it's a string, we have another. Like I need to check if it's a string or not, and then just yeah, it should be fine. Oh shit! Wait, no. I need to check it. Do I need to check it again? No, I have. Okay, wait. How do I interpreter cast chart T into what exactly? Into like I need to know. Okay, so I'm doing like call entries, right? I mean this launches dot push. Oh shit! No, actually, I need to create a new vector, but that's not the point. My problem is that I need to check this twice, I'm guessing, right? Or I can just... because I need to initialize it first, right? And to initialize it first. And also here I need to check what size of I'm taking. So, oh wait, no, I can add it here. Just serialize it with the size, right? Which I fucking did. And I just forgot about it, so yeah. So I take the size, and then if it's, okay, should be fine. So, again, class T, oh, I do need that, hold on. So class T stood vector, T, stood vector T, that, and entries. And oh, I didn't close. Oops, I didn't close it here. What the fuck? This, the turn. Extra. Okay. Anyway, so like this. Oh. And let's create. We should create a variant, right? Create a variant. No, just switch. Switch. When wait, no, switch, right? Switch entry size. Size of int if it's size of int, then int entry int 0 in read interpreter cast char entry int and size of int, right? And in here just entries dot push back. Wait, what do I push back? Entries dot push back entry int. Now wait a minute. Do I need a switch case? No, wait, no, I don't. I don't. Why do I even? Switch, so I need to erase this. Okay. So T entry 1, T entry 2, and now. In dot read. So I don't need this, right? In dot read. Oh. In interpreter cast char, right? On entry to add size of size effect size. Wait, interpreter cast. Let's change it because it's kind of amount of entries equals 0. So yeah, so I want to get right in here. Entry to add size of T. Size of entry to add. I think I need some sticks for here somewhere, but I don't know how. Let's build and see all the errors I have. Right. Entry size. Right. Amount of entries. Build. Oh shit, nice. Entries. Oh, and so for size ti equals 0, I is less than amount of entries, I, and just move it here, and entries dot push back entry to add. Nice. I don't think this will work, especially on the first try, but I'll try. Okay, I'm gonna stream for another half an hour, probably, something like that, and end for today. Probably is what will happen. Okay, is it all? Yes, and I don't need to return anything. That's nice, right? That's nice. Okay, let's see. I created columns here, so let's just serialize sir dot serialize column ci column TCI. Oh wait, I need to pass in. Oops. I need output file and input file. Right, so let's go here and as binary, so stud off stream. Stud off stream. See out. That. Well, I mean, this is dot that, so I also put dot that. I don't know what exactly. It's like what's that what do you call it? Forgot. Extension. I don't know what that extension, but it used ci.dat, then I will also use ci.dat. So initialize column. What goes first? The out goes first into the column. So ci out. I stood heap stream ci in ci.dat stood iOS binary also, right? In temp. Yeah, also and this, sorry, and third dot in this serialize column, the in DCI. And let's go with, where is it? Where was I? DCI. Let's here print the column. Do I have print column? I do have print column. Able cd. Where's print column? Print column. Right, I do. So it should be fine. So DCI dot print column. And let's comment this everything else out. So don't log stuff, right? And again, probably won't work. What? At least let's build and see what happens. Is private within this context. Oh, right, that's a class. I just construct. No, what the fuck? Okay, build. What? Unfinished deserialize call. Serializer HV. What do you mean? The CMake in function main undefined reference serializer deserialized call. Deserialize. What do you mean undefined reference? Oh my fucking god. I am indeed stupid. Build. Oh shit. Debug. Fuck. Segmentation fault. Right. I'm guessing this. Okay, let's debug it like that. Size of name 7. Right. All of those fine. This is the problem apparently. Where was it? Here it is. So 0 and 1, that's int. I think I need to write it somewhere. That's segmentation fault here. Okay, let's size t entry amount. Just a second. Sorry about that. Anyway, so entry amount is 0. Yeah, so entry amount all dot entries index might end in here. I'll just pass this. You can, right? You can hear me? Yeah. This size of entry amount. Maybe now, please. Oh. Okay, this did work, but what? No, outright text size. Size. Do I need this? Wait. Vec type size. To deserialize it. Out.write interpreter cast char vec type dot size. Oh yeah, that's the amount of entries. Wait, then what the fuck that? Oh, that's type. Oops. That's entry type. That's entry type, and let's go with size t vec size equals vec type dot size. That's entry amount actually. That's entry amount. Right, so this size of entry amounts. Entry amount. Okay, debug. Oh fuck, I did something. Where's the file? Hey yo. Wait, should have printed. Why didn't it print anything? Because I deserialized it. What? The fuck? Oh, again, debug. Oh? Serialize object. Oh, I need to close it. Alright. I need to close it. Main. Out.close. And here is scene.close. Build. Oh my God. Build. Debug. Oh, it fucking worked. Where's the file though? Oh. Where's the file? Let's, you know what, let's put it in. It puts in that, in build. Right, so, obviously. So, instead of putting it in build, let's put it in. Let's create here. Let's create here a folder, not inside src, Jesus. Inside this folder, fuck off. Folder, thanks. That files. Right, and then we can just that. Like that. And like that. And build, I can just delete this. Right. Build. Debug. Why didn't it print anything? What? That files. Did it create new? It doesn't create new ones. Doesn't seem so. So build, debug, worked. Nice. Let's have home. Let's have a string one. I want to check this one because it's kind of scary. Row str equals. Oh, it's a column. Oops. Column str. Yeah. Equals hello world. I am serializing. Okay, and create a column. So column CS. So it's a column string, and let's have str on. Let's go. I'm good with names, as you can see, and call str. And now let's serialize the string column. Call str. Let's call it DC, like this serialized column, so we can reuse it. DC dot. Wait, that's no, that's a different column, I'm guessing. Let's call it CS, right? CS. CS. So and call string. No, CS. Right. CS DC. In here, CS dot right and C enclose DCI print column. Let's see if string works. Let's hope it works. What the fuck? DC. Oh, DC. DC build debug. Fuck. Fuck. Did it Okay, did create cs dot dot. Didn't print the column though, which is not nice. Not nice. Called string. God. So why? Why wouldn't it work? I mean, I checked it. Like, maybe it's, you know, oh shit, I know why. Okay, that's a quick fix though. That's a quick fix though. I did save. Where is it? I did save. Yeah, here I did save the length of each string, right? Is it here? Yeah, I did save the length of each string, but in the deserialization I did not include that. So in here, if it is a string, I can use like size t. I can use it to be equal 1, and it is a string, then let's try the size t. Pom pom pom. If entries at I equals 2, if stud is same, if stud is same, t stud string value, then size t yeah, size t size mult equals 1, right? If it's a string, I need to provide, wait, in here, let's say, right, we have, we need to resize, right, we need to resize the string. Did I resize the string here? Oh, no, only, okay, only in there I need to resize. So, yeah. That won't go, I don't think so. So size t, string length equals 0. Goes before, right? I hope so. Should go before. Let's serialize. String length, size, string length. Yeah, it writes first of all string length. Writes string length and then the string itself. Okay. So my string length is 0. In dot read interpreter cast char string length, right, and size of string length, right, and now in in. Oh, and now pom. To the string, entry string, string entry r calls entry to add. Oh, sorry. Str entry str dot resize, right? Yeah, resize. String length, and then read, pass in the reference of the 0, the length, and oh, and that's it. So here's MSP and pom. So in dot read entry string and 0 and the length. Okay, and the length. String length. Okay. And read and then that's supposed to be it. And else that. Let's do that. Let's actually here. So build. Nice. Let's remove this cs.dat. Right. And debug. Fuck off. Now why? Now what's the fucking problem? Build. Debug. Oh no, it will be even worse. Oh. Did I remove the correct one? I hope I fucking did. Debug. It's just being a cunt. I just that delete it. Yeah. And let's debug and see what's the problem. So do serialize, close DC, serialize. Okay, so DC string call entries. Yeah, not good. I did exactly what I had to do. So we have entry string, right? The size else oh my god, oops. So let's put and debug. Interesting. What the fuck? Oh wait. Const expert. Jesus. Why didn't it scream at me though? Build. Okay. Delete. No, don't need this. And the bitch. I need to delete. Let me check how to delete files. Code just a moment. Remove. Why is that in Japanese? Stud remove. Deletes the file identified by the character point value. Okay. B. Stud remove. Point tool. Build. And okay, debug. What the fuck? Entry to add. What? Huh? Um, let's go here. Var index 3. That's char. Oh. Oh, wait. Thinks that's a char. Why does it think that's char? What the fuck? What do you mean? Var index 3. Read 12. Why is var index 3? Tree amount, no. What are I write index? We have entry type, right? That's the second one. We have read name, read column name. Let's actually this third, right? And var index. Var index. Okay. But why? Debug. Is that out? It's called out. It's called out. And this called in. In. Okay, so out. This in. Right. Out, and I'm taking in CS. So the yup. Build. Entry type column. String column entries hello blah 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 blah. Then call entries dot index. What the fuck? Stupid. What? 3? Oh, maybe I'm stupid? And string before char? No way, right? String is not before char. 0, 1, 2, 3. Am I even stupider than I thought? I'm starting with I'm not. 0, 1. Oh. Fuck. I really am stupid. What? I spent time on this. There's no way I spent time on this shit. No, just fucking finish the program. Unknown var index 3? Now what? 0, 1, 2, 3? Ah, I didn't break. Oops. Build. Debug. Fuck. Now what? 0, 1, 2, 3. Debug. The var index is 3, right? So it's supposed. Oh. What? Okay, string length 0. Read string length 5. Size. Oh, I didn't push back. Oopsie. Entries. Dot push back. Tree string. I'm sorry. I yeah. Now it's gotta work. So, hello world, I'm serializing. Nice. I serialized the column. Arguably the easier of this stuff. Right. Okay. Now, I'll be ending soon. I'm just see, see and think what and talk about what I think should do next. Because that's the first time I'm serializing. So first of all, can I do it more generic, like just template shit, right? That's problematic because I don't know what fields I need to serialize. I can. I can add sort of like. Wait. If I use state. No. Yeah, I think I just need to add this serialization to get rid of the serializer, right? It's just not really necessary. It doesn't serve a purpose. It doesn't hold even, what is it? Doesn't even hold anything. Like just a bunch of functions. I don't know what can it hold. Like I guess path. It needs to be able to serialize this for now. Column, table. Well, a column is part of a table, so yeah, a column, vector of them, vector of columns, and the B tree. Yeah. And one approach I'm thinking about is just adding serialize here, like in table adding serialize, and column adding like this already. And this is for the column, so adding this serialize and deserialize, and for the table the same, right? And one for B tree, and just run both of them, right? Also, I can, let's see. So, let me think. Basically, like, again, the one approach is doing it just adding serialize on each one of them. Let me make it smaller. Serialize on each one of them, and the other approach maybe be. I mean, I can't really make it generic unless I use a boost library or something, but I don't want to mess with that right now. It's kinda, it's a lot of. I'm working on Windows, so yeah, that's a lot of. That's not fun. Okay. Anyway, I'll be serializing. Probably I'll be doing for a table. I mean, I have already one for a column. For a B tree, serialize and deserialize. Can I do it maybe with some inheritance? Is it possible? Like not public inheritance, like protected one, right? Not sure, but I think the naive approach, like the easiest approach, is easiest. And yep. So I'll add serialize to each one of them, and probably in database, this is actually useless. In database, I'll have how it's called. In here, I'll run like the serialize everything and deserialize everything, and then the logic behind it, like what to do with it. Now, I didn't even read like exactly how the B tree should interact with the serialized stuff. So I'm guessing I'm creating a B tree, right, of storing keys. Storing keys in the B trees. Then I deserialize only the B tree because it's supposed to be lightweight, right? In one place, lightweight in one place. And when a user asks for this table, I serialize using find like using the B tree, like finding it in the files. I understand I can have like something with offset. Like I know the offset. Like, yeah. That's probably how I will implement it. Probably. I think also think about it more later and read about it more later because I'm not 100% sure how the bit tree is supposed to interact with serialization and deserialization and stuff like that. Again, my guess is I'm supposed to create a bit tree, serialize it, and then create and say I have already like some tables serialized, right? And yeah, just find exactly what table I need to deserialize using bit. But the problem is, say the user say I want to deserialize this table, right? And I'm storing keys. So I know I can just go to the file with that name. That's probably search. In turn, that will probably search. I have to search file by file. And with Bitry, I can just say, no, again, that's indexed. It's just indexed. I don't have to search. I know. Oh, that only works. Okay, I get that only will work if there's no deletion. Anyway, yeah, and with the Bitry, I can just say jump this amount of files and take this file based on things I will read. And okay, this is probably this is it for today. I hope I'll be able to stream. I hope I'll be able to stream next week. Next week, next week is the 22nd. I don't remember if I can stream this. I probably won't be able. No, I don't know. I'm sorry, I don't know. Anyway, this was fun. I learned a lot about serialization, deserialization, and I'll try to prepare for next stream and be ready to actually implement some more serious serialization, deserialization stuff. So that's it. Sorry, I read something. I was confused. Sorry. So, thank you for watching. This was fun and engaging, and I hope you enjoyed. I did, and yeah, see you next time. If you have any questions, ask in the comments. And I hope, yeah, have a good week. Bye bye.